All right, guys, back chapter 3. This time it's section 3.3, dispersions of central or measures of central tendencies and dispersion from group data. So remember, group data is where we have the classes, lower class limit, upper class limit, class width, and a frequency associated with each of those. So we have discussed how to compute descriptive statistics from raw data, but often only data available have already been summarized in the frequency table or group data. So although we cannot find exact values of the mean or standard deviation without raw data, we can approximate these. So here we have our population mean, sample mean. With these, we have like the sum of all of these variables. So I know it looks a little weird, but we have the product of the value times the frequency. And we're getting the sum of all of those. We're dividing it by the sum of all the frequencies. And it's going to be the same for both of these right here. So multiplying all of those values together, adding up all those values or all those products, then also adding up all of the frequencies separately and then dividing the two. Same thing, only population mean is still denoted by mu, Greek letter mu. Sample mean is denoted by x bar. So x with that little line above it. And let's get started with this one. So the frequency distribution in the table 13 represents the total fine, including late penalties in dollar for a simple random sample of 50 parking and camera violations in the city of New York. Approximate the mean fine. So here we're going to take a picture of the data. So here and here. Perfect. We're going to take it right over to Excel. Here, insert data from picture. And it's going to be one of the latest screenshots. All right, class amount. This one looks a little funny, so let's go ahead and make it a tag mark. This one looks a little funny too. The rest look good. Don't really care much about that, but insert data anyway. All right, so here we have our classes and here we have our frequencies. So this is where some of the computation comes from. Do we know exactly how many or exactly what the value of this one frequency in here is? We don't really know the exact value because we don't have the raw data in front of us. But what we could do is guess, right? So are we going to guess super low within this class or super high within this class? Are we going to get the smallest value or the largest value? So again, we don't know what the exact value is of this data set. So instead of just guessing, we're going to get the average of this class. So the average of this class is going to be that middle number. And here it looks a little weird because we can't really calculate our middle number, right? Remember when we're drawing our histograms? So when we draw our histograms, we have our boxes touching. So they're touching because all of the data within this box here could be anywhere between this value here at the end and this value over here at this end. So what we're going to do to measure the middle right here is find the middle value from the beginning of this class and the beginning of this class. So for this very first class here, we're going to get the middle between 50 and 75. To make it a little bit easier for us, let's separate this into two separate columns. So in order to do that, again, you don't really have to. What you could do is look at the midpoint and just calculate that on your own. But let's be a little bit lazy and actually try to learn this. So if you're not interested, you guys could go ahead and forward the video. But we're going to first start with putting a space between what we're going to have this lower class limit and this upper class limit. So now we're going to grab this data and we're going to highlight it. And to separate these two, we're going to go over here to data and text to column. So text to column. This is going to separate, telling it whatever command we have is going to separate the two. So here we hit next. Over here, we could either separate with tab, but we don't have any tabs over here. We could separate with semicolons. That's if we add a semicolon between these two, comma, space, anything. So we're going to hit other because they don't have that command to separate between these tack marks. So separating between those tack marks, that's what it is. So this is what the list looks like right now, and this is what it's going to look like. We had to put that space here in the middle first, because if we didn't have the space here, the data would have nowhere else to go. We would have to like overlap them. So from here, we just hit next, finish, and it separated our data for us. Now what we have here is the lower class limit, and we have the upper class limit. So now the frequency, perfect. So the frequency from values between 50 and 74.99, there's only one. There's 0 between 75 and 99.99. There's 7 between 100 and 124.99, so on and so forth. So now for the midpoint, we talked about our histogram. So within our histogram, each of these boxes go from a certain value all the way up to, this is just a random data set that I'm drawing. So it goes from those limits. So what we're going to do to find the midpoint within each of these boxes, we're going to look at the lower limit and the upper limit of these boxes. So the lower limit, or yeah, lower limit of the first box and the lower limit of the second box to get the lower limit of that middle value of that first box. So again, midpoint here. And this midpoint is measuring this value right here in the middle. So it's measuring this middle point, which ends up being the average of that class. So the average of this class is going to be the average of the lower limits of the two classes. So here, the middle point, we add the two numbers together and divide by 2. That's how you find midpoint. So we have 50 minus 75, I'm sorry, 50 plus 75. Let's just start all over. So equal to 50 plus 75. And make sure we have parentheses around that. And then we're going to divide that by 2. So that's going to give us the midpoint, halfway between 50 and 75. And now we're going to do this all the way down, and we could just drag and drop because, again, we want to be a little bit lazy. So now looking at this very last one, just to make sure, well, let's look at one of the middle ones. We'll talk about the last one here. So this one here is 200 and 225. The middle of these two values ends up being that 212.5, which makes sense, looks good. So now the reason why this one did not actually act the way we wanted it to is because this very last number doesn't have a number underneath it. So one thing we could do is put that 325 here, because 325 is the next number. So 50 plus 25 is 75, plus 25 is 100. Keep going. We have 275 plus 25 is 300, plus another 25 is 325, and it gives us the middle of that data set right there. So works out perfectly for us. And we could just leave it like that. Let's make this font white. Perfect. Now it doesn't even look like it's there. All right. So now that we have all of this, let's go ahead and get started with the computation of the mean. So remember, the mean here is going to be equal to the sum of xi times the frequencies, and we're dividing it by the sum of the frequencies. So first thing we're going to do is here, x ends up being the midpoints because that's the value that's representing each of these classes. So the one value that represents each of these classes is going to be this value here. So again, we're only going to concentrate on this data. So for right now, let's just kind of, I don't know, let's make it a little obvious that it's not exactly part of the data set. All right, looks better. So from here, looking at just this data set here, midpoint is representing the midpoint between this class here. So that way we could get an average, because we don't want to highball it or lowball it. We don't want a higher medium or a lower medium here. Frequency is how many of each are in this class. So we have that. So next we're going to say X times our frequency. So X times the frequency, just to label everything. So here we want our value X, and we want to multiply it by the frequency. So equal to our value X multiplied by the frequency. And that makes sense because we don't have any there. So let's grab this, and nothing has to freeze. We want everything to go down, match each other all the way down. So now we have this value here. So we're really close to having the values that we need. Let's switch this over so we could see it. We are really close to having the values that we need. Right now we have the product of each of these. Now we could get the sum of each of these. And we also need the sum of the frequencies. So let's go ahead and get the sum here. And the sum is going to equal sum of all of these. Oh, that's fine. So equal to the sum of all of these. Make sure you have either click that command or put the parentheses there so we could get them. All right, 50, and this does make sense because when we read over here, it talked about the 50 parking violations. So perfect. Now that we have that, this is a number that isn't going to be that predictable. So here was the sum of frequencies. This is going to be the sum of X times the frequencies. So equal to sum, parentheses this time, of these values here. All right, almost perfect. And from here, what we're going to do is find the mean. So the mean altogether ends up being the quotient of these two numbers. So us dividing these two values. And was this? No, this was X bar. Because this is a sample, simple random sample of 50. All right, tab, we have X bar equaling, and I should fix this right here. So it's X bar equaling all of these values. Much better. Okay. So X bar is equal to the sum of the products divided by the sum of the frequencies. So sum of products divided by the sum of frequencies. And there we go, 182.5. That ends up being our sample mean of the finds that we collected, or the data that we collected from the finds. And let's see if we missed anything. So again, we found our midpoints, the frequencies, the product of the frequencies, then we had the sum of the frequencies, the sum of the products. And there we go. We divided the two, 182.5, 182.5. All right, so now the approximate mean find is 182.5. All right, caution. So we computed the mean from group data in the example, even though the raw data is available right now, unless we go back and look for the section that we worked on, that we first work on this, and we find the data from that section, then we do all that. We could compare it, but it's going to be a little bit different from that data. It's going to be roughly off by, I'm not exactly sure how much, but it's going to be off. It's not going to be, this is just an approximated mean because we don't have the raw data immediately in front of us right now. So the reason for doing this was to illustrate how close the two values can be. So in practice, raw data, use the raw data whenever possible, because that's going to give you a more exact or more like a better approximated value of the mean. We just happen to not have the raw data, so we would just do it from there. All right, so now compute the weighted mean. So weighted mean is going to be just the tiniest bit different from the group data. So the weighted mean X bar of W of a variable is found by multiplying each value of the variable by its corresponding weight, adding these products together and dividing the sum by the weights. It can be expressed using this formula. So weights, so instead of it being F for frequency, we have W for weights. And the two could kind of go hand in hand, but it's not exactly frequency, right? It's going to be a little tiny bit different. All right, so Marissa just completed her first semester in college. She earned an A in her 4-hour statistics course, a B in her 3-hour sociology course, an A in her 3-hour psychology course, and a C in her 5-hour computer programming course, and an A in her 1-hour drama course. Determine Marissa's grade point average. All right, so what we have here, GPA, like specifically for this course, even though we should be meeting, what would it be, like 8 hours a week, because this is a fast track class, it's still considered a 4-unit course or a 4-hour course. So kind of think of it as like a regular semester, we would have 4 hours per week. So that would be a 4-unit course. Not always, just approximated. Okay, anyway, so let's go ahead and take down all that data. All right, so starting off with statistics. She has an A in statistics, which is 4 hours. A B in her 3 hours sociology. A C in her 5-hour computer programming. I'll just put CP for computer programming. We missed one, an A in her 3-hour psychology. A C computer programming, and an A in her 1-hour drama course. And let me see how they compute it. All right, so they're saying an A is 4.0. So actually, let's take this over to Excel so we could kind of see it a little bit better. All right, so we have statistics. Sociology. Sociology. Computer programming. Psychology. And drama. And we'll call this one class. This is hours. And this is grade and value for the grade. All right, so statistics was 4 hours, sociology was 3, computer programming was 5, 3, and drama was 1. The grade she ended up getting was A, B, C, A, and A. And what it looks like they did is they gave a 4 for A, a 3 for B, a 2 for C, and I'm guessing it would have been like a 1 for D. So let's clear that out and see what her grade point average is. So her grade point average is going to consist of like her hours end up being the weights, and the grade value ends up being, or hold on. Yeah, hours end up being the weight. So we could say that hours are W's, and the grade value end up being X. So the grade value of X and how many hours we spent with each of those. So here again, what we're looking for is X bar or X. Yeah, so X bar equaling the sum of the weights times our value X, and we're dividing that by our weights. All right, so starting off with that, let's get the product of the two. So let's get our X times W. X times W, much better. All right, so this is going to equal X, and we're multiplying that, so times little asterisk W. And not one of these are fixed. As we drag this down, we do want these all to match each other. So we just grab this corner and bring it down. And now we have the product of all of these. So we have the products. Next, we're going to do is find the sum of the weights times the other ones. Let's see. So we're looking for the sum of the product. All right, the sum of X times W. And we're also going to look for the sum of the weights. So the sum of the products is going to be equal to the sum. So sum of the products and the sum of the weights. Sum of the weights. Perfect. And now for the mean, X bar ends up being the quotient of the two. So X bar is equal to the product divided by the weights. There we go. So that's 3.185. So 3.0 is equivalent to like a B average. So she got slightly above a B average in her classes. And let's see if we missed anything. So 3.19, 3.1875 looks good. So Marissa's grade point average for her first semester is 3.19. So now we could kind of talk about the difference between the two. The what do you call it? The mean for group data is based on frequencies, but here we don't really have a frequency, right? The frequency of each of the classes, it ended up being like the frequency of hours. So we can't really call hours frequency. So that's what makes the weighted mean a little tiny bit different. Just kind of summarizes all the other data that doesn't have a frequency. All right, so now we're going to approximate the standard deviation of the group data. So of group data and also of weighted data. So approximate the standard deviation of a variable. So looking at this, remember the standard deviation of a population is always going to be denoted with sigma. Standard deviation of a sample is going to be denoted by an S. Another difference is here we're using population mean for this population standard deviation, sample mean for the sample standard deviation. Here, the frequency is being, the sum of the frequency is the number of observations. So here it's the capital N because it's the entire population. Here it's little n, and remember we're dividing by n minus 1 for these. So it makes these a little bit different. So let's see what the data holds. And we have our algebraic version too, but we're going to concentrate more on the one that we just saw. All right, so the data in table 13 represents the total fine included, blah, blah, blah. So that's the data that we have right over here. So let's concentrate on that one. Let's see, approximate the standard deviation. So here, remember, we're looking at a simple random sample. So this is going to be sample data that we're looking at. So sample data, let's kind of throw this over here. So I want it, there we go. So this is sample data. All right, so now with sample data, first thing we have to do is we already have the mean, right? So the mean ends up being 182.5. But let's look at this just a little bit different. So we're looking at, this is S for standard deviation, and it's the square root of the sum of our deviations from the mean. So X minus X bar squared times the frequency, and we're dividing it by the frequency or the sum of the frequencies. All right, so looking at this data, let's grab or actually we could just continue on from here. All right, so we have the midpoints, which is our values of X. We have the frequency, which is our values of F. X bar is this value that we have right here underneath. So let's start with that. So we have the deviations from the mean. So we're going to do that with the midpoint. And we have our deviations from the mean. So X minus X bar. I could just leave this down here at the corner. So X minus X bar. So here it's going to be equal to X, this value here, minus X bar. So I know it's kind of hard to see, but we have X bar way down here. And we're going to hit enter, and that solidifies that first one. What we're not changing is X bar. X bar is the same for all of these values. So we're going to freeze or fix X bar here. So that way, when we grab this corner down here and drag it down, it takes along all the data with it. So we have all of this, that's this part right here. Next thing we're going to do is square these values. So that way we could square them. After that, multiply the frequency. So up here, we're going to label this as X minus X bar squared. And all we're doing here is squaring each of the values in the previous one. So this value raised to the power 2. And we're doing that to all of them. And it works out perfectly for us. All right, now that we have that value, we have X minus the bar, or X minus the mean, perfect. We squared it, perfect. Next, we're going to multiply it with the frequencies. So I'm just going to write it a little bit different so that way it doesn't bother us too much. So the frequency times X minus X bar. And we're raising that to the power 2. Just because if we write it the other way, it kind of looks like that's being multiplied to that 2, which it's not. So here we have our frequency F. So this times the value that we got in the previous column. So our deviations are our deviations from the mean squared. And within these two, neither one of them should be fixed. We want those to be paired up as we go down. So we don't have to use any dollar signs here or money signs. We just drag those values all the way down. Perfect. Now that we have that, the next thing we have to do is figure out what the sum of those deviations are. So here, we'll just label this as the sum of these values. There we go. So we have the sum of these values, and I'm just going to type it in underneath. So this is going to be equal to sum of these values here. And we also need the sum of the frequencies. Ooh, but we already have the sum of the frequencies. And it's kind of bothering me that we don't have the summation sign there. And summation sign here too. All right, so now that we have the sum of the deviation squared times the frequencies, we have the sum of the frequencies. Next, to find our value of S, it's just going to be the quotient between those two, and we need the square root as well. So for S squared, this is just before we take that square root sign, so it's equal to the sum of the deviations squared times the frequencies, and we're dividing that by the frequencies themselves. And I messed up. This should be the one right underneath it. So 15. Yeah, perfect. So just so you could see it, the sum of the frequencies squared, or sum of the deviations squared times the frequencies, divided by the frequencies themselves. And now we have that value that also known as our variance, but we're looking for standard deviation. All right, so standard deviation is just the square root. So right now the number that we have is this number on the inside. Now we just have to take the square root of it. So we have that number on the inside, take the square root of it. So SQRT for square root. And we want the square root of this value here. And there we go, 53.619. And let's see if we missed anything. Just a little tiny bit off. Oh, ouch. I actually messed up. So remember that I said this is the mean of our sample data. So it's 1 less than the frequency. So remember it's n minus 1. So n here is the frequency, but we should have subtracted 1 from it. So coming back over here, it should be the sum of the frequencies minus 1. And see how that makes the tiniest difference. There we go. So 54.163. Earlier we had 169, I believe it was. But yeah, just the tiniest difference made a little difference in our solution too. But make sure it's, we're looking at the degrees of freedom. So remember, degrees of freedom is 1 less than our number, or 1 less than the observations that we have. And observations is just our frequency here. All right, and there we go. Again, this is just an approximation because we don't have the raw data in front of us, but this is a good approximation of the entire data. All right, so approximate the mean and standard deviation of the find data in table. So we don't have a TI-84, so it's still same thing here. But that's it. That's section 3.3. If you guys have any questions, don't forget to email me. But if not, good luck on your homework. Bye, guys.